Hello everyone, this is the last video in the series of the Lab 1 measurements that we did as an introduction how to use Python in combination with Arduino to perform measurements, engineering measurements of various processes in the industry could be done. So we build gradually our difficulty. We started just taking the set of measurement, and then we started to take it continuously. Then we not only took it continuously, but we wanted to plot it. And now we even want this stage to keep our data for post-processing. So I kind of put all these tasks in here. As I said, gradually came up to this moment, and you might see that from 1 to 4 are exactly like the same task that we had previously, and now we had the last task, number 5, that we want to keep that data. Moreover, I a little bit rearranged the loop here basically because I wanted it to plot in a more nice way, like generate a square wave. And for the reason you can see here, I put 20 values, 20 data points that I am generating first. I'm taking the LED on and off as a square wave, and it's visible on the screen when we are plotting the data. And for that reason, we are using a for loop inside of the while loop for the moment when we turn it on, and we keep it 20, get the 20 measurements while it's on, and we print those measurements in real time. So you can see that will slow a little bit down the process because we print it, but just for the sake of showing it, I'll go there. Then we turn it off, and again we keep it off for 20 measurements that we acquire. And then at the end of the one iteration of the while loop, not the for loop, we are plotting all those 40 points that we acquired, 20 and 20, in a plot in the figure. So you're supposed to get a nice square wave. I also modified, moved my this white jump wire. I moved it between the two, the LED and the resistor, like it's shown here in this image. So I moved it there because initially it was right here where I had 5 volts or close to 5 volts. Now I am supposed to get less than that because it will be a voltage drop on the resistor. So I call this as a midpoint, say. So if we are here, we supposed to get like 5 volts. Here is supposed to get somewhere like 2 point something volts because of the voltage drop of the resistor. I think I have 100 ohm resistor there. And then if we move that, in this case I put it as a green jumper wire. So if you move this jumper wire here, right here at the end, then you're supposed to get a 0 voltage. It might be meaningless, pardon me, but just for the sake of checking, you can do that, and you see if you really get, you will not get a square wave in that case. I mean, you will still get the square wave, but the measurements will be not seen as a square wave because the LED will be on and off, but you will be connected to the ground always. So basically, this is the whole setup, and we want to keep the data that I put it here in the number 5. As you can see, I am basically taking those two time column and voltage, the two arrays, voltage array and time array, and squeezing them. So I create a 2D array that is like a spreadsheet. You have a time column and a voltage column, and then I put them together and save them as a text file, as a comma separated file. Python works very good with this. And I think I take it with 3 decimals. That's exactly what I'm putting there. I also put a header to my file. You can see for the time column in seconds and voltage that I measure in volts, exactly how I calculated. So let's go ahead and run this. If you install it at your machine, you will see. So I put it there. So I started to communicate with the board, and now I am turning the LED on for 20 measurements, and I'm acquiring the data. Then I turn it off for 20 measurements, and then I'm plotting the square wave. As you can see, I have 20 points there, 20 points here, and again I'm continuously doing it, as you can see there, on and off for 20 points. It looks more like a nice square wave in this case. So if I stop it, I am supposed to basically get the data in my folder where this original file was located. So and mine, it was located here in lab 1 measurements. And if you look here, I don't have any measurement there, nothing whatsoever. I interrupted the loop, but the data was not saved, although it was there. So in order to do this, we have to put another procedure. We have to use a try procedure, try except procedure that is available in Python. So I have to tell it, try this, try going in the loop, and run it as long as I am telling you to do it. And then when I want to get out of the loop, but execute this code. It was not executed in the previous one, so I have to force Python to execute it. So I put that try, and now I have to select this whole code, the whole all the way up to here at the end, the whole while loop, and indent it one step to the right. So I'll select everything there, and I hit the tab key. And I indented everything to the right one step. So now you can see the whole while loop is in this try. And again, I apologize, I didn't want to type all of it and keep it there, so I comment this with Alt 4. And now basically what it tells, execute the loop, go there and execute it, and except when I am hitting the key interrupt, which is press Ctrl C in the shell, and then it will get out and will execute whatever it is after it. So that's let's try this time so you can see if it really does it. And we'll go again, acquire some data points with our square wave. As you can see. Alright, so now let's say I'm done and I want to get out of here. So I'm gonna go here and say Control in the shell. I'm gonna click, say Control C. So you now see that it got outside of there. It told me that it executed the code because I told it to just give me that. Let me see if I can move this and come here. And I apologize, I hope you guys seen this. So the code, so it executed, and I told this comment there, where was it? This one right here. So if I go back in my shell, you will see that it put that comment there, press Ctrl C to terminate the while statement, and it did that. That's the exception, and then it went to execute this code. And so now we check if it really did it. So right now, if you guys see, it just put it there. So if I double click it and open it with Excel, it's a comma separated file. It has 3 decimals, and the first time column you can see is the time, and the second is the voltage. So if I am selecting these 2 columns and plot them with the insert, and I come here for 2D plots, you guys can see that it's exactly the voltage that I acquired. And because I moved this jumper wire to the midpoint between the resistor and LED, you can see that I am grabbing right now 2.5, 2.7 volts, 2.8 volts. So that is because that's the voltage that drops on the LED, not the 5 volts. So as it was when we were measuring before the resistor. So I hope this helps, and you can see how you can keep all the data. It's not complicated, and save it for further post-processing in this. So I'll put this file on the our website, so you can copy and paste it and run it with your Arduino board, and it's not complicated. I hope you enjoy it, and I hope you guys have a beautiful day.